This is my geometry course. Today we're going to continue to learn area. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. Now in this course we're going to learn how to find the area of the segment of a circle, which we're going to do today. And in the next class we're going to learn how to find the area of a regular polygon and also the surface area of regular pyramids. And a lot of teachers skip that material. And the reason is that this part of the course can be somewhat rocky because you have to combine a lot of concepts that we learned in previous classes all at once to do those particular problems. And for that reason, it's often difficult for students and for teachers. And so a lot of teachers will just say they just skip it completely. But I'm not going to skip it because, well, there are 5 reasons. Number one, it is part of the curriculum. And even though you're less likely to see this stuff because a lot of teachers don't cover it, there is a chance that you may see it on a placement exam or somewhere, so I'm going to cover it for that reason. Secondly, you're going to have to review trigonometry, and that's going to help us. As you can see here, reviewing the trigonometry is going to be good for you. And the third reason is that we're going to review the basic idea of how to find the area of a triangle. And the fourth reason is we're going to review how to find the area of a sector. And also number 5, the fifth reason is that we're going to review the special triangles. So we're going to review all that information which is going to help you with the material in this course. So we're going to go ahead and cover those 3 topics I mentioned, because in doing so we're killing 5 birds with 1 stone. So that said, let's get started. As you can see, we're going to cover a trigonometry review first, and I know what you're thinking. You're thinking, I was hoping that I would never have to see that stuff again. Because this stuff is typically very intimidating for students for multiple reasons. As I mentioned in the class where we learn this stuff, there are 2 reasons that students are intimidated by this. Number one, it's function notation, and we haven't learned function notation yet. You've got these strange letters and the Greek letter there, and it's kind of confusing. The second reason that this stuff is very intimidating for students is that you're not really you're not taught a complete understanding of this stuff. You just kind of plug this stuff into the calculator and it spits out a number, but you're not expected to have a complete understanding, and that introduces anxiety when it comes to covering this stuff. But I want you to understand that you're not expected to have a complete understanding of this. You're only expected to know how to use it. I can assure you that there is no K-12 student who has a complete understanding of these expressions. You're just not required to have a complete understanding. And even when you go into college, even the college professors themselves are typically not expected to have a complete understanding of this notation. So don't be intimidated by this. Don't let this introduce anxiety into you, because like I said, you're not expected to have a complete understanding of this notation. And if I expected you to have a complete understanding, it would be like me teaching you how to drive a car, but telling you that I'm not going to allow you to drive the car until you take the entire car apart and disassemble the engine and the electrical system and the brake system and the suspension, and tell me how every single part works first before I allow you to drive the car. Well, you would probably say, well, I'll just drive the bus. I don't want to do that. Well, that's kind of the way it is with this stuff. You're not expected to be able to explain all of it. You just have to know how to use it in problems. In the same way, if you're driving a car, you just have to know how to drive the car. You don't have to know how every part works. So let's get started with our review problem for this trigonometry. Also, be aware that this notation only works for right triangles. You use these expressions for other triangles, but these expressions on their own by themselves are only used for right triangles. You see we have a right triangle with a 90-degree angle, and one of the other angles is 59. And we have an unknown side, and we have a known side, the hypotenuse. And I know that's the hypotenuse because it's opposite the right angle. Now, if this angle is 59 degrees, that means that this angle by the triangle sum theorem must be 31 degrees. And so we're going to use the trigonometry to find the unknown side, x. And remember, trigonometry gives you relations between the sides and the angles of triangles. The Pythagorean theorem gave you relations between the sides, and the triangle sum theorem gave you relation between the angles. But this notation gives you relations between the sides and the angles. We have an angle here, actually 2 angles, and given this angle and this side here, we're going to find the unknown side x. Now, I'm going to bring those trig ratios over here so we can see exactly what's going on. Now, this angle here is 59 degrees. We're going to use that as the reference. This side is the opposite side, and this side is the hypotenuse. So we need one of these ratios with the opposite side and the hypotenuse, and you can see that's going to be sine. So sine 59 degrees is equal to the opposite side over the hypotenuse, and then we're going to rewrite, because we're going to show what's going on here. Now, in a previous class, what I would do is I would write this over 1, and then we just cross multiply. But, and you can do that if you want. Then you would end up with 8 sine 59 degrees equals x. But what I'm going to do is just use the method we learned in my beginning algebra course. I'm just going to multiply both sides by the lowest common denominator, which is 8. And there's only one fraction, so obviously that whatever that denominator is, that's going to be the lowest common denominator. And you could think of this as, again, over 1, and then our denominators would be 1 and 8. The lowest common multiple of 1 and 8 is 8. So we're multiplying both sides by 8, and we get x is equal to 8 times sine 59 degrees, and you don't really need the parentheses there. You can just leave those off. That just means multiplied. And at that point, we have the x value. All we have to do is just go to the calculator. So in the calculator, you can write the 59 first, then push the sine button, then times 8. Or you can push 8 times 59, then the sine button, then equals. And you should get the same answer either way if you're using an iPhone. If you're using an Android, you have to enter the sine first, and then I think you write the angle. But again, it just depends on your calculator. So you're going to need to figure that on your own. So we get 6.86, and the units are centimeters. And I told you to round off to the nearest hundredth. So make sure that you do that. And so now, number 2, using this reference as this angle as a reference, we have opposite side and adjacent side. So which one of these has opposite and adjacent? Well, that would be tangent. So we're going to write tangent 45 degrees. 43 degrees is equal to opposite side over adjacent. And then, as we did in the previous problem, we're going to multiply both sides by 2. And on the left side, you can use parentheses if you want. You don't really need to. I'm just using the parentheses to emphasize that we're multiplying. So now we get out the calculator, and we have 2 times 43 tangent equals, and I get 1.87. So 1.87 meters. And there you go, we found that unknown side. All right, on to the next problem. We're going to do one more of these before you try one on your own. Now, using 25 degrees as a reference, we have the adjacent side and the hypotenuse. So we're going to use the cosine. So cosine 25 degrees is equal to adjacent over hypotenuse. And then we're just going to rewrite that just to show the operation, what we're doing. And we're multiplying both sides by m. And this is different because the variable is in the denominator. So m is the lowest common denominator, so you just multiply both sides by m, and we get m times cosine 25 degrees. And my class on equations with fractions in my beginning algebra course may help you if you're stunned by what we're doing here, the algebra. Or you can go back to my course or my class in this course where I talk about the basic trig. That might help you. So now we need to, the only purpose of multiplying both sides by m was to get rid of the fraction. We haven't isolated m yet. So now we have to get m by itself. It's not by itself because the cosine 25 is next to it. So we have to get rid of the cosine 25. This is m times cosine 25, so we have to do the opposite of multiplication, which is division. Those cosines cancel out, and you end up with 12 over cosine 25 degrees. And then we just get out the calculator. So 12 divided by 25 cosine equals, and we get 13.24. So 13.24. Now, I want you to be aware of something before you attempt these problems on your own. There's a lot of buttons in your calculator that look like sine, cosine, and tangent, but a lot of them are not. For example, if you have sine -1 power x, something like that, that's wrong. Okay, don't use that. Also, you might see sine hyperbolic. So that's the wrong one also. You should also be aware that your calculator needs to be in degrees. There are degrees and there are radians. Now, sometimes when your calculator says radians, that means you're in degrees. And sometimes when it says degrees, that means you're in radians. So it's very confusing. But just make sure that you're in degrees. You're going to find with trial and error, just by looking at the answers that I gave, whether or not you're in the right mode. So go ahead and try number 4. I have these trig functions here and also here. And I have the practice problems. So attempt number 4, and when you come back, we'll do it together. All right, we're back. Now, using 38 as a reference, we have the adjacent side and the hypotenuse. And so adjacent and hypotenuse, that uses cosine. So we have cosine 38 degrees is equal to x over 7. And multiply both sides by 7 to get rid of that fraction. And we end up with 7 cosine 38 degrees is equal to x. And now we can just get out our calculator. 7 times 38 cosine equals, and I get 5.52 millimeters. So if you got that answer, good job. So now, if you didn't get that answer, it might be that you're not entering you're not pushing the buttons in the right order in your calculator, or your calculator might be in the wrong mode, or you're using the wrong wrong function or whatever. But try number 5, and when you come back, we'll do it together. All right, we're back. We have, using 41 degrees as a reference, we have the opposite side and the adjacent side. So opposite and adjacent, that's tangent down here. So tangent 41 degrees is equal to the opposite over the adjacent. And as usual, we're going to multiply both sides by the lowest common denominator to get rid of that fraction. And we have 23 times tangent 41 degrees is equal to x. And x is approximately equal to, so let's get out the calculator, and we have 23 times 41, tangent button, equals 19.99. And that is meters. So if you got that answer, good job. Now, if you're kind of confused by the adjacent and the hypotenuse side, remember the hypotenuse is adjacent also. All right, this side is adjacent and the hypotenuse is adjacent, but we don't call this the adjacent side. It's always called the hypotenuse, so just be aware of that. So if you got that answer for number 5, good job. Go ahead and try number 6. We're going to try one more of these before we go on to our sector review, finding the area of a sector. Be aware that number 6, the variable is going to be in the denominator, so it's going to be a little different. So attempt number 6, and when you come back, we'll do it together. All right, we're back. Using 46 degrees as a reference, we have the opposite side over the hypotenuse, or opposite side and the hypotenuse, so we're going to use sine. So sine 46 degrees is equal to the opposite side over the hypotenuse. And the first thing we're going to do is get rid of that fraction. Whenever you have an equation with fractions, the first thing you want to do is get rid of the fractions. So we're going to multiply both sides by the lowest common denominator, which is b, because there's only one fraction in the first place. The b's cancel out on the right side. You have 9 is equal to b times sine 46 degrees. And now we still have not isolated b. All we've done is just get rid of the fraction. So we have to isolate b, so you have to get rid of that sine 46 degrees. and it's multiplied. This is multiplied into b, so you have to do the opposite of multiplication, which is division. And those sine 46's cancel out. We're left with b is equal to 9 over sine 46 degrees. And finally, b is approximately equal to, let me get our calculator out, 9 divided by 46 degrees, and then push the sine button, and then equals, and we get 12.51. So if you got 12.51, good job, and that is inches. So again, that's just trigonometry review. I know that a lot of students don't like that stuff and don't want to see it, but you can't avoid it in the next course, Intermediate Algebra. Well, actually, it'll be in the course after the next one. You're going to go over and you're going to have an entire course just on trigonometry. So you can't really avoid that stuff. But if you got that answer, good job. Now we're going to review how to find the area of a sector. Remember, this yellow portion here is the area of a sector. Or that is the sector. We're going to talk about how to find the area of the sector down here, but a sector is just a region in a circle bounded by 2 radii and the corresponding arc. So to find the area of the sector, you take the total area of the whole circle, which is pi r squared, and multiply it by a fraction, determined by this central angle here. So we're just going to do 2 practice problems on this before we continue on, and we do the stuff that is going to be new, stuff you haven't seen. So we want to find the area of this green sector region. So area is equal to the central angle over 360 times pi times the radius squared, and all we have to do is simplify that, and we're pretty much done. So we can just enter that into the calculator. 50 divided by 360 equals, then times pi equals, then times 16 equals, because 4 squared is 16. So we get 6.98 square meters, and be sure that it's square meters, because this is area we're finding. And if you try to do this in your calculator, if you try to write the 4 and then the square button, it might present some problems, so just be aware of that. So try number 8, and when you come back, we'll do it together. All right, we're back. The area is equal to the central angle divided by 360 times pi r squared. And so the area is approximately equal to, in your calculator, push 128 divided by 360 equals, then times pi equals, then times 9, because 3 squared is 9, and then equals. And then we get 10.05. And make sure you write square inches, not just regular inches, because we're finding area. So if you got that answer, good job. So we reviewed the basic trigonometry, and we also reviewed how to find the area of a sector. And now we're going to use all that information to find the area of a segment of a circle. Now, you need to be aware that the word segment has been used to describe or to name a line segment. This is a segment, right? But now we're changing the definition of the word. It's going to be very confusing, because now when we refer to a segment, the segment of a circle specifically, that is something completely different. If you draw a chord in a circle, let me make that a little bigger, then that creates 2 different regions, this region here and this region here, and both those regions are called segments of circles. This is the smaller segment, so it's called the minor segment, and of course the other segment's the major segment. And so I know it's very confusing, because we're using that same word that describes something that is completely different from an actual line segment. But you're just going to have to make a mental note of that. So what we're going to do now is we're going to learn how to find the area of the segment of a circle. We're going to learn how to find the area of this green portion here. Now you see down here we have a chord, and that chord creates a major segment, and it creates a minor segment, this green part. We only care about the minor segment because we're going to find the area of this minor segment. we're going to find the area of this portion here. And to do that, we're going to find the area of this sector, this whole part here. We're going to find the area of that, and then we're going to subtract the area of this triangle. And that's going to give us the area of the green part, the area of the segment. And we form this triangle by drawing two radii to the endpoints of the chord. That's how that triangle is formed. That's how this process works. So that's what we're going to be spending the rest of the day doing, just finding the area of segments. And it's not something that is exactly a simple process. And that's why a lot of teachers, as I said, skip this. But it's not that it's going to be hard. It's just that it's not going to be, it's not exactly a one-step process. So let's practice some of this. We're going to find the area of this green segment down here. Now, I want you to be aware that there are formulas that we could come up with that would make this a lot easier. But I'm not going to show you the formulas because, number one, it's going to be difficult to remember the formula a month from now or a year from now when you have to take a placement test. And also, number two, the whole point of this class is to reinforce your concept of area. And if you just learn a formula where you can just plug in numbers, then you're really not going to be reinforcing anything. The formula would make things go a lot faster in these problems, but again, you're not going to learn the concepts. So we're going to do steps. The first step is the easiest step, or at least we're going to make it the easiest step. It's the area of the sector. The area of this sector, which is this whole part, we're going to first find the area of all of this stuff here, everything. So we're just going to use our formula for the area of a sector, and that's going to be the central angle over 360 times the total area of the circle, which is pi r squared, as usual. So then we're going to get an approximation for that. And so we enter 100 and then divided by 360 equals, and then times pi equals, and then times 64 equals, because 8 squared is 64, and then we get approximately 55.8505. Now notice that I carried out more decimals there than usual. That's because this is only an intermediate step in our calculations. So you want to carry out more decimals so that we don't have round-off error. And in these problems, I'm not really, I didn't tell you how many decimals to round off to. So let me go ahead and do that now. So there you go. Round to the nearest hundredth. I forgot to write that. All right, so we found the area of the sector. And again, if you carry out 4 decimals here, that's going to give us enough to have accuracy to the nearest hundredth. So now we're going to find the area of the triangle, and this is going to be the part that is somewhat involved. So the area of a triangle is 1/2 times base times height, and so it's easy to find the area of a triangle. It's not hard. The problem is we don't have the base of this triangle or the height. That's why these problems are going to get kind of involved. We have to find this length here, the height, and we have to find this length here, the base. And we're going to use trigonometry to do that. So what I'm going to do is I'm going to take this triangle and pull it out. I'm going to put it over here, and it's not going to be a perfect, it's not going to be exactly the same. As you can see, I'm making it bigger, but it's not really necessary to make it exactly the same. You know, it's just for our reference to see what's going on here. And we know that these two sides are both 8. Now, how do we know that? Well, we know this side is 8, right? But this side must also be 8. Do you see why? Well, obviously, these are both radii. So all the radii of a circle, they have to be all the same length. Those are all 8. Well, I didn't draw it all the way to the circle, but you understand the point. So those two sides must both be 8. So what we're dealing with here is an isosceles triangle. And what we're going to do is we're going to drop down the height, and we're going to drop it down, obviously, so it's an altitude, so we have a 90-degree angle there. And what we need to do is we need to prove that this triangle is congruent to this triangle. And it's pretty easy to do that because we can use the HL triangle theorem. That says that if you have right triangles, these are both right triangles, if you have two right triangles and the hypotenuse of each triangle is congruent, they're congruent to one another, and also you have a leg that's congruent, because this leg, this altitude is common to both of the triangles, then that proves that the triangles are congruent. So we know, again, that this triangle is congruent to this triangle. Now, if you know that the triangles are congruent, you know corresponding parts are congruent. So what that means is that this length here is the same as this length. I'm going to call those both x. And also you know that this angle here must be congruent to this angle. So if those two angles are the same, and we know they must both add up to 100 degrees, because again, that's the central angle, 100 degrees, I wrote that there, then that means you can just cut those angles in half, and now you have 50 degrees and 50 degrees. Now you might be thinking, well, who cares about all that? Why do we care? Well, if you pull the left triangle out, you can pull the right one out too. It doesn't really matter which one. Then we're going to call that altitude h. That's the height. That's what we're looking for in this triangle to the left. And this side, we're going to call it, it's still x. And that's a 90-degree angle. And we're going to use this triangle to find the height and the base of this triangle. So if we find h, we have the height of this triangle, the height right there, this length here. And if we find x, we can multiply that by 2 to find the base of this triangle. All right? So I know this seems kind of complicated, but once we do all that, the rest of the problem is going to be easy. And for these problems, you don't have to show this every single time. I'm just showing it for your sake so you can see what's going on. And this is why a lot of teachers just skip this stuff. But the problem is you can't really skip it because it's part of the geometry curriculum, and all this stuff are things that we learned in this class. You need to review it. So why not take this opportunity to go ahead and review it, since you're learning, since you're using it to learn how to find the area of a segment. So we're first going to find the height, and I know it's kind of it's not a really good thing to go from right to left here, but we're kind of out of room there. So we're going to use, obviously, this angle as a reference, and we need to find h using the hypotenuse. So that's h is the adjacent side, and we have the hypotenuse. So bringing these down. So the adjacent side and the hypotenuse, that you can see is going to be cosine here. So cosine 50 degrees is equal to the adjacent side over the hypotenuse. And I got to get these out of here. Hopefully you can see those over here. So then we're going to multiply both sides by 8, and I'm not going to show all the algebra. I think by now you should understand the algebra. And so the height is equal to 8 times cosine 50 degrees. I'm going to circle that and actually maybe use a different color. So that is the height. And I'm just, circling it so you can section it off. You can see what that work is all about. That's all about finding the height there. Now over here, it's all about finding the base. So we're going to use sine to find the base. So sine, because we have, using 50 degrees as a reference, we have the opposite side and the hypotenuse. So we have sine 50 degrees is equal to the opposite side over the hypotenuse. And multiply both sides by 8, and we get 8 times sine 50 degrees, and that is x. That's not the base. Okay, we have to keep going in order to find the base. So the base, which we're going to call b, is equal to 2 times x, you see, because we're looking for the base of this bigger triangle. The base is equal to 2 times x, which we just found is 8 times sine 50 degrees. And so we can simplify that a little bit. You can just multiply these two numbers together. I know that you're not used to seeing that, but just get used to it. You can put those together. So now we have the base. All that we just did there was just to find the base of the triangle. So now we're going to put all that stuff together and actually find the area of the triangle. So the area of the triangle is equal to 1/2 times the base, which is 16 times sine 50 degrees, and then we'd have to multiply by the height, which is 8 times cosine 50 degrees. And let me move that over a little bit. So now at this point we could simplify all that, but rather than get kind of complicated with all that type of stuff, it's probably best to just enter it in your calculator. It's not hard to simplify it, but we don't really have a lot of experience with that in this course. So we'll just enter the numbers in now. So 0.5, that's the same thing as 1/2, 0.5. It's going to be better to just write 0.5 instead of writing 1 divided by 2. And then times 16 equals, then times 50, then the sign button equals, then times 8 equals, then times 50 and the cosine button, and then equals. And we get 31.5, well, let's just carry it out there. So 31.53, whoops, 5138. So now we're going on to step 3, the final step. So the total area, or the area of the segment, is equal to the area of the sector minus the area of the triangle. And we can just plug in those numbers, and we get 55.8505. So that's the number that we found up here. That's the area of the sector. And minus the area we just found, 31.5138. And go ahead and do that in your calculator. And you can keep the number that we just found in and just subtract 55.8505. And you'll get a negative number, but you can just change it to positive. So the area of the segment, rounding to the nearest hundredth, would be 24.34, and the unit is square centimeters. So I know that seems pretty complicated, but just be aware that you don't really have to show all of this work. That problem took a lot longer just because I was showing you every single step and drawing pictures and so on and so forth. So when you do your homework, you're not going to have to show all of that stuff, so be aware of that. Don't be discouraged by the amount of work we had to do there and all the stuff we had to write. So let's try number 10. I'm dragging these functions along with us. So the first step, as usual, is to find the area of the sector. I'm just going to put this up here. So area of the sector, that's the easy part. That is the central angle divided by 360 times the area of the circle. And in your calculator, 81 divided by 360 equals times pi equals times 25 equals, because 5 squared is 25. And we get 17.6714. So now, well, that was step 1. Be sure to label your steps. Step 2, we're going to find the area of the triangle, which is equal to, as usual, 1/2 base times height. So I'm going to take that triangle out. Now notice that our triangle is kind of, it's kind of upside down because we want this to be the base. So it's a little hard to picture, and I just want you to know that you could drop an altitude here, and that would, you could use 81, but in order to do that, you would have to find these angles first, and you could do that, but that would require more calculations. So we're just going to take this triangle and set it so that this is the base. And so I'm going to draw that out. And again, these triangles that I'm drawing are not exact, so if it ends up being a little off, that's okay. It's just the picture, the general idea is what you need to know. So again, we're going to drop an altitude down, and we know these two sides are 5, and that inner angle there, that top angle, is going to be cut in half. So we're going to have, it's going to be 40.5 degrees for each one of these. It's kind of hard to fit that in there. And as usual, we're going to call these sides X. And so now we're ready to take out that left triangle, and again, you can take out the right triangle if you want. We're going to call this side H, and this angle is 40.5 degrees. This side is 5, that's a right angle, and this side, of course, is X. So now we're going to find the height of this triangle, and I should probably color that to let you know what triangle I'm pulling out there. So to find the height, we need the adjacent side and the hypotenuse. So you see our trig functions up there. That's going to be cosine. So cosine 40.5 degrees is equal to the adjacent side over the hypotenuse. Multiply both sides by 5, and we get 5 times cosine 40.5 degrees. That's the height. So all that work was just to find the height of the triangle. And be aware that this triangle is turned. Again, this is the base. It's turned, it's kind of turned upside down here, so we had to flip it around. So now we're going to find the base, and we're going to use sine for that, because sine is the opposite side over the hypotenuse. We need the opposite side, and we have the hypotenuse to use to find the opposite side. So sine 40.5 degrees is equal to x over 5. Do the algebra, and x is equal to 5 times sine 40.5 degrees. But we haven't found the base yet. The base is equal to 2 times x. So 2 times what we just found, 5 sine 40.5 degrees. So base is equal to 10 times sine 40.5 degrees. So all that we just did was to find the base. That was the purpose of that. So now we're going to combine all that work we just did to find the area of the triangle, because we have the area of the base, or we have the base and the height. So area of the triangle is equal to 1/2 times the base times the height. And I'll move that over a little bit. So the area of the triangle is approximately equal to, and again, we could simplify that expression, but just to make things easier, I'm just going to have you enter it in. So 0.5 times 10 equals times 40.5 sine button equals times 5 equals times 40.5, and then the cosine button, and equals. So we get 12.3461. And again, I want you to carry out 4 decimals there to avoid round off error in the last stages of the problem. So the area of the segment is equal to the area of the sector minus the area of the triangle. So the area of the segment is approximately equal to, go up to the area of the sector, 17.67, 17.6714, and then minus the area we just found, and enter that into your calculator. And we get our approximation is 5.33, and the units are square feet. So again, it takes a lot longer when you're trying to explain all this. But when you do these problems, you're going to understand all this logic because you're going to have done so many problems today that when you do the homework, you're just going to know what to do without showing every single step. Okay, so on to number 11. But before we do number 11, get a screenshot of this information here. That was the first problem that we did. And, if you want to, you can get a screenshot of this information. And I'm going to leave the problem that we just did in the window. So I want you to try number 11. And, go through all the steps here. And when you come back, we'll do it together. All right, we're back. Step 1, the area of the sector is equal to 48 over 360 times the area of the circle. Enter that into your calculator. 48 divided by 360 equals times pi equals times 36 equals, because 36 is 6 squared. And remember to carry out 2 decimal places. I forgot to remind you to do that, but you should have done that, or else you're going to have round off error. So that was step 1. That was the easy step. And now we're going to find the area of the triangle. And the area of the triangle obviously is equal to 1/2 base times height. So we have to take that triangle out. And it's going to look something like that. Again, these triangles are not exact. It's just to show you what's going on. So that top angle is 48 degrees, but when you drop the altitude down, it's going to cut that angle in half, so it's going to be 24 and 24. And this side is 6, that side is 6, and we're going to call these sides x as usual. Now we're going to take one of those triangles out, and we have 24 degrees. We're going to call this height 6 and x and a right angle. And again, we're pulling it out, pulling this triangle out. So now let's find the height of the triangle. We're going to use, using 24 as a reference, we have the adjacent side is the height. So, and we're going to use the hypotenuse. So adjacent and hypotenuse you see up there at the left, that's cosine. So cosine 24 degrees is equal to h over 6. Multiply both sides by 6, and we get 6 times cosine 24 degrees. And so that was all to find the height of the triangle. So now we're going to find the base of the triangle. As usual, we're going to use sine because x is opposite. We're trying to find x. And we're going to use the hypotenuse. So opposite over hypotenuse, you see up there, that's sine. And multiply both sides by 6. And we found x. We don't want x. We want b. b is 2 times x. You see why? We want the base of the bigger triangle. There's a lot of stuff going on here, so you really have to pay attention to what we're doing. It's not hard, it's just involved. So now we can simplify that a little bit, and we get 12 times sine 24 degrees. That's the base. So all that we just did there, all that work was just to find the base of the triangle. So now, as usual, we're going to combine that information. So the area of the triangle is equal to 1/2 times the base times the height. Now we get out the calculator, and 1/2 is 0.5, so just put 0.5 for 1/2 times 12 equals times 24, then the sign button equals, then times 6 equals, then times 24, then, oh whoops, that should be a cosine button. then the cosine button, and then equals. That should be cosine, not sine. Sorry about that. So then we get 13.3766. So now on to step 3. We're just going to finish it out. So the area of the segment is equal to the area of the sector minus the area of the triangle. So the area of the sector is 15.0796. And the area of the triangle we just found. So if you have that 13.3766 in your calculator, you can keep that in there and just push minus 15.0796 equals, and you're going to get a negative number, but that's okay because we can just change it to positive. Obviously, we know it's going to be a positive number. We just kept it in there so we didn't have to write both numbers. So now we have 1.7, and the units are meters, so 1.7 square meters for the area of that segment. So if you got that answer, good job. Again, you don't have to show all this work necessarily. You can kind of jump forward through this because it kind of gets tedious to have to show that. All right, so again, if you got that answer, good job. On to number 12. So go ahead and attempt number 12. Let me bring these trig ratios down just in case you need those. You can find these trig ratios on the internet pretty much anywhere, so you can use those. You know, you don't have to use these yellow expressions if you don't want to. You can just look on the internet. So try number 12, and when you come back, we'll do it together. All right, we're back. Step number 1, area of the sector is equal to 145 over 360 times the area of the circle. So get out your calculator. 145 divided by 360 equals times pi equals times 9 equals, because 3 squared is 9. So then carry out those decimals. You want 4 decimals just to be safe. And step 2, we're going to find the area of the triangle. That's the hard part. It's equal to 1/2 base times height. The problem is we don't have the base or the height. Sorry, just waiting for my computer to speed up there. So we're going to take this triangle out, and we're considering this side to be the base, so we have to flip it over. So we're going to flip it like this, and it's going to look something like that. Again, your triangle doesn't have to be perfect. So this angle is 145 degrees, and we're going to drop the altitude down. Use our same variables as usual. Again, these lengths are obviously not the same. They're kind of off there, but it doesn't really matter. These sides are both 3, and these angles are going to be 145 divided by 2 as usual. So 145 divided by 2, you can do that in the calculator if you need to. So 145 divided by 2 is 72.5. 72.5 degrees, 72.5 degrees. And we're going to pull out the left triangle. Again, it doesn't really matter which triangle you pull out. They're both going to be the same. They're both congruent. And we're going to call that the height, and this side is obviously x. And now we're going to find the height of that triangle, because the height of that triangle is the height of the bigger triangle. And to find the height, that's the adjacent side to the angle 72.5. and we want to use the hypotenuse. So adjacent and the hypotenuse, that's going to be cosine, which is adjacent over hypotenuse. Multiply both sides by 3. So we found the height, and we're just going to leave it in that form. Now we're going to find the base. That's going to use sine, because sine is opposite over hypotenuse. So we're going to find the opposite using the hypotenuse. So x over 3, multiply both sides by 3, and we get 3 times sine 72.5 degrees. And we don't want x, though. We want the base. The base is 2 times x. So 2 times the value we just found. And of course, we can simplify that to 6 times sine 72.5 degrees. So all that we just did there was to find the base of the triangle. So now that we have that information, we can use it all to find the area of the triangle. That's 1/2 times the base times the height. Let me shrink that a little bit. And now we can get out our calculator. So 1/2 is 0.5, so 0.5 times 6 equals times 72.5, and the sine button equals, then times 3 equals, then times 72.5, then the cosine button equals. So the area of the triangle is 2.581. And the next digit is just a 0, so we don't have to write that. So step 3, area of the segment is equal to the area of the sector minus the area of the triangle. So area of the segment is approximately equal to, and just keeping that, well, we should probably write it first. So 11.3882 minus 2.581. Again, we're getting the area of the sector up there. So doing all that, you can keep that 2.581, so on and so forth in your calculator, and push minus 11.3882 equals, and you're going to get a negative number if you do it that way, but we just change it to positive, so we have 8.81, and the units are inches, so square inches. If you got that answer, good job. That's a lot of work to do, and if you're getting the right answer, that means you're really, really learning a lot of information. If you didn't get the right answer, that's okay. It's typical to make some sort of a mistake somewhere along there. That's okay. That's completely normal, but you got to go back and figure out what you did wrong. So on to number 13. We're kind of just doing more of the same thing, but in this problem, there's a slight difference. You're going to see what the difference is. So let's do number 13 together. In the previous problems, we were given the central angle. We were given this angle here. But in this problem, we're not given the central angle. So, how do we do this? Well, these two lengths are radii, and that means that it's an isosceles triangle, right? This triangle here is isosceles. So based on the isosceles triangle theorem, or the converse of the theorem, I forget which one is which, but if we know that these two lengths are equal, that means that the opposite angles of those lengths must also be equal. So that means that if this angle is 41, then this angle must be 41 also, and we can use those two angles to find the central angle using the triangle sum theorem. If we call this circle C, we'll just label that C, then the measure of angle C plus 41 plus 41 is equal to 180. And just doing the math on that, we get the measure of angle C is equal to 98 degrees. Now we have the central angle, and it's the exact same problem that we did before. So that was step 1. That was just an extra step there. And step 2 is going to be finding the area of the sector. So 98 over 360 times pi r squared. And get your calculator out. 98 divided by 360 is equal to, and then times pi is equal to, and then times 1, because 1 squared is just 1. So we get 0.8552. And step 3, we're going to find the area of the triangle as usual, which is equal to 1/2 base times height. Now we're going to have to take that triangle out, and it's a 98-degree angle, so it's going to look something like this. Again, it doesn't have to be perfect. So drop down in altitude. This angle is 98 degrees. If we divide 98 by 2, we get 49, so both these angles are 49 degrees. Both these sides are 1, because those are radii. As usual, this is x. This is x. Pull out the left triangle. We're going to call that height, and of course this side is x. So now we're going to find the height. So we have 49 is the reference angle, and we're looking for the adjacent side, and we're going to use the hypotenuse to find the adjacent side. So looking at your trig ratios on the right, the yellow, we're going to use cosine. So we have cosine 49 degrees is equal to the adjacent side over the hypotenuse. And so the height is equal to cosine 49 degrees. That was all just to find the height of the triangle. Now we're going to find the base of the triangle. I guess we can do that here. The base, we're going to looking for x and using the hypotenuse. So x is the opposite side of 49 degrees, so we need opposite side. That's going to be sine as usual. You're seeing patterns here. Sine 49 degrees is equal to the opposite side over the hypotenuse. And then it just simplifies. X is equal to sine 49 degrees. So now we want to find the base, because we don't really want x, we want the base. So that's 2 times x, so 2 times sine 49 degrees. And we can just simplify that and get rid of the parentheses. When you're multiplying a trigonometric ratio, you don't really need the parentheses. You can just put the number right in front. So all that was just to find the base of the triangle. So now we combine that information. Area of the triangle is equal to 1/2 times the base times the height. So the area of the triangle is approximately 0.5 times 2 equals times 49, the sine button, equals times 49, the cosine button, equals. And we get 0.4951. So now on to step 4. The area of the segment is equal to the area of the sector minus the area of the triangle. The area of the segment is approximately equal to 0.8552 minus the number we just found. And so you can leave that 0.4951 in your calculator and push minus 0.8552 equals, and that'll give you a negative number because we subtracted incorrectly, but you can just change it to a positive number and round off to the nearest hundredth, and we get 0.36. And what are the units? Units are inches, or square inches, excuse me. So just another example of one of these problems. All right, so go ahead and try number 14, and we're going to call this center C. You have to call that center something. And remember that this angle is 32, therefore this angle must be 32 also. And you have to use that information to find the central angle. So I'm going to put my trig information down here so you can see that. And go ahead and try number 14, and when you come back, we'll do it together. All right, we're back. So step 1, find the central angle. So the measure of angle C plus 32 plus 32 is equal to 180. And if we do the math on that, we get the measure of angle C is equal to 116 degrees. Step 2, we're going to find the area of the sector, which is 116 over 360 times pi r squared. So in your calculator, 116 divided by 360 equals times pi button equals times 144, because 144 is 12 squared. So we get 145.7698. Let me shrink this a little bit. All right, step 3. Area of a triangle obviously is equal to 1/2 base times height. And we're going to take that triangle out. Again, it doesn't have to be perfect. This angle here is 116 degrees. Divide it in 2. 116 divided by 2 is 58. So each of these angles is 58. And 12, 12. That's supposed to be an isosceles triangle. It doesn't really look like it, but you get the point. And take out the left triangle, and now we're going to find the height. The height, we're going to use adjacent and hypotenuse. So sine 58 degrees equals adjacent over hypotenuse, and that's actually should be cosine, I'm sorry. Cosine is adjacent over hypotenuse, as you can see up there. So h is equal to 12 times cosine 58 degrees. So all that was just to find the height. Now the base, we're going to use sine 58 degrees because that is opposite over hypotenuse. Therefore, the x value is 12 times sine 58 degrees, but we don't want x, we want the base, which is 2 times x, as you can see up there, even though the picture looks weird. 2 times x, x is 12 sine 58 degrees. Simplify, and we get 24 sine 58 degrees. So all that was just to find the base. So now we're going to combine that information. And the area of the triangle is equal to 1/2 times the base times the height. So the area of the triangle, we do 0.5 times 24 equals times 58, then the sign button equals, then times 12 equals, then times 58, then the cosine button equals. All right, so step number 4, we're going to find the area of the segment by subtracting. It's the area of the sector minus the area of the triangle. So it's approximately equal to, area of the sector was 145.7, 145.7698. We're going to subtract 64.7131. So you can keep that 64 in your calculator, minus 145.7698 equals. So the area of the segment is approximately 81.06 square centimeters. So if you got that answer, good job. Okay, on to number 15. Now these next problems are going to be pretty easy. In fact, that's all we're going to do for the rest of the day is just these easier problems. See, the difficult thing about the previous problems, like I said, was finding the area of the triangles. But in certain situations, it's actually going to be easier to find area of the triangles because you're going to have, you're going to have a special situation. So for number 15, you see the special situation is we have a 90-degree angle. So what that means is that this length, this radius is the height, and this side here is the base. So finding the area of the triangle is going to be really easy. But let's start off with the area of the sector. Step 1, area of the sector is equal to 90 over 360 times the area of the circle. So 90 divided by 360 equals times pi equals, and then times 49, because 7 squared is 49. All right, step 2. Now, this is going to be the easy part. Usually it's the hard part, but area of the triangle is equal to 1/2 base times height. And now we don't really have to do much work because we know the base is this part here, which is 7, and the height is this part, the other radius, which is 7 also. So the area of the triangle is exactly equal to whatever that stuff is there. So 1/2 is 0.5, so 0.5 times 7 equals, and then times 7 equals. So we get 24.5. So now we're ready to combine all that. Area of the segment is equal to the area of the sector minus the area of the triangle. Area of the sector is 38.4845. Area of the triangle is 24.5, and this has to be an approximately equal to sign. So we can just take the 24.5 and minus 38.4845 equals, and we get 13.98 square centimeters. So as you can see, that was much, much easier. So I want you to try number 16. Number 16 is going to be pretty much the same type of problem, but the triangle is kind of orientated in a way that's hard to see, so just be aware of that. But the base is going to be 2 meters, and the height is going to be 2 meters, depending on how you set the triangle. So go ahead and try number 16, and when you come back, we'll do it together. All right, we're back. Step 1, area of the sector as usual. So that is 90 over 360 times pi r squared. So 90 divided by 360 equals times pi equals times 4 equals, because 2 squared is 4. Now the second step, area of the triangle, is equal to 1/2 base times height. The base is 2 and the height is 2. And we get 2. Last step, area of the segment is equal to area of the sector minus area of the triangle. And again, you don't have to write all of this out. As long as you know the basic idea, you're good to go. So area of the sector is 3.1415. Then we minus 2. And we don't really even need a calculator for that. We can just see it's equal to 1.1415 square meters. So if you got that answer, good job. So again, those were the special situation where the central angle is 90 degrees. So we could jump forward on that particular example. All right, on to number 17. In this problem, we're going to need a special triangle also. Well, we don't need it. We can use a sine, cosine, and tangent, but we have 120 degree arc, and remember the measure of the corresponding central angle is equal to the corresponding arc. So that means that this angle must be 120 also. So now there's a couple ways we could do this. One way is we could drop an altitude down here and deal with things that way, but that's going to be a little confusing. So we're just going to stick with splitting the central angle in half. And so, but before we do all that, let's find the area of the sector. And in the calculator, 120 divided by 360 equals, times the pi button equals, times 16 equals, because 4 squared is 16. And we get the following number. And now we're going to find the area of the triangle. So let's go ahead and pull out that triangle, and we're going to see that this is going to turn into a special triangle, which means that we don't have to use the sine, cosine, and tangent stuff. So this angle is 120, and of course area of a triangle is equal to 1/2 base times height, and this side is 4, this side is 4. Drop an altitude down. And we have a 90 degree angle, and so we're going to cut that angle in half. Obviously we're going to get 60 degrees, and 60 degrees, that's half of 120. Now here's where the special triangle stuff comes in. If this angle is 60 and this angle is 90, then that means that this angle over here is 30. So if you recall, 30, 60, 90 triangles are special triangles. We learned that in a previous class. If you don't remember it, that's okay. But now you've got it right in front of you, this relation between the sides of a 30, 60, 90 triangle. So you see it right there. So I'm going to pull out the left triangle. We call that side the height. And so now we know the hypotenuse. Now you're going to have to pay attention to this if you don't remember how to use these special triangles over here. Pay attention. We have the hypotenuse. The hypotenuse is 4. But what this tells us is whatever this number is, whatever side this is, the side opposite the 30 degree angle is going to be half that, because this side is 2 times W. So if this side is 4, then that means that this side must be half of 4. Now you're probably thinking, whoa, wait a second. Shouldn't it be this side? You're talking about this side, right? Well, no, the triangles are kind of orientated in a different direction. It's the side opposite 30 that is half of the hypotenuse. The side opposite 30 is h. So don't be confused because this triangle is orientated differently from this triangle. So long story short, that means that the height is going to be 2. So I don't really need to section off a part to write the height because it's pretty obvious. So that comes from here, and this number. So that's the height, and the base, that's x, and x is going to be, x is the side opposite 60. Now we found that w is 2. I mean, that's what W equals, because if you take 2 and multiply it by 2, you get 4. and that's the hypotenuse. So W is 2, so we can just plug in 2 for all the W's, and we see that the side opposite 60 degrees is just 2 times root 3. That's how special triangles work. We've done this many, many times before. And we're going to write x is equal to 2 root 3, but we don't want x. We want the base, and the base is equal to 2 times x. So 2 times 2 root 3, because x we just found is 2 root 3. So the base is equal to 4 root 3. And if you don't remember how to do that, simplify that, you can go back to my class on simplifying expressions with square roots in my beginning algebra course. So now we're still on step 2. We're going to find the area of the triangle is equal to 1/2 times the base, which is 4 root 3, times the height, which we found is 2. And so it's probably best just to enter that into your calculator. So 1/2 is the same thing as 0.5, so 0.5 times 4 is equal to, and then times 3, and then the square root button equals, and then times 2 equals. And again, the square root button on your iPhone is going to look something like this, or on an Android it might look like you might have to push the square root button first and then put your number here. It just depends on the device you're using. So we got the area is approximately equal to 6.9282. So now, finally, step 3, we're going to calculate the actual area of the segment. So the area of the segment is approximately equal to the area of the sector, which we found up here is 16.7551. And then we're going to subtract the area of the triangle, which we just found. So you can keep that number in your calculator, minus 16.7551, and we get a negative number because we subtracted in the wrong order, but that's okay. We can just change it to a positive number. And you want to keep that number in your calculator so you get an actual, so you don't have to deal with round-off error. So 9.83, and the units are millimeters. So we have square millimeters. So again, the difference with that problem is that we could use a special triangle. In the first problems that we did today on the segment, the area of the segment of a circle, we had to use the sine, cosine, and tangent functions. But in these problems, we can use this special triangle. So I'm going to copy that special triangle and bring it over so you can use it on the next problem. I'm going to put that there. And for the next problem, again, you're going to use this 30, 60, 90 triangle. And what you're going to do is you're going to drop down the altitude, and you're going to split that 60-degree angle in half, so that this angle here is going to be 30. And of course, this is an altitude, so that would be 90 degrees there. And the reason we care about that is because using the triangle sum theorem, this angle here must be 60 degrees if this angle up here is 30 degrees. And that's how you're going to generate this 30, 60, 90 triangle. So go ahead and attempt number 18. I'm going to leave number 17 in the window. And when you come back, we'll do it together. All right, we're back. So before we do anything, let's find the area of the sector. So 60 divided by 360 equals times pi equals times 100 equals. And we get 52.3598. And now the area of the triangle. So we're going to take that triangle out. It'll look something like that. 60 degrees. Drop in altitude. Obviously these would be 30 degrees. And 10 and 10. X and X. Pull out the left triangle. And now the height. Again, we're going to have to use this special triangle now. So we know that this side is 10. So that means that the side opposite 30 has to be half 10, right? One way to do it is to set 2w equal to 10 and divide both sides by 2. We see w must be equal to 5. So once we know that W is equal to 5, then we can find all these sides really easily. So the side opposite 30 must be 5, so that's x. And the height is going to be 5 times root 3. Because again, we know W is 5, so the side opposite 60 must be 5 times root 3. So the height is 5 root 3, and the base is just 5. There's really not a lot of work to show there because we can use these special triangles. So now the area of the triangle is equal to 1/2 times the, actually I forgot, we gotta finish that out. So the base, x is equal to 5, not the base. So x is equal to 5 and the base is equal to 2 times x, and x is 5. So the base is equal to 10. Now another way to have done this problem is to recognize that these have to be 60, so it's an equilateral triangle, so all the sides are 10. That's another way we could have done it. But that would not have given us the height. We still would have needed to find the height. That would just give us the base. So now the area of the triangle is 1/2 times the base times the height, which is 5 root 3. Therefore, the area of the triangle is approximately equal to, and you got to be careful here because we have a root. So it's 0.5, that's 1/2, times 10 equals, times 5 equals, then times 3, then the root button equals. And we get 43.3012. Part 3. Area of the sector is 52.3598. And just plug those numbers in, and we get the area of this segment is approximately equal to 9.06 square feet. So if you got that answer, good job. Now, I didn't mention that another way to do this problem is to drop an altitude this way and consider this to be the base. If you did it that way, then you would have 60 degrees obviously here, but then this would obviously be 90 degrees, which means that this angle would have to be 30. So you could also consider the triangle that way. All right, on to number 19. We have 2 more problems. Now, in the previous 2 problems, we used the 30, 60, 90 triangle, and we don't really need those trig expressions anymore. In these problems, we're going to use the 45, 45, 90 triangle. That's the other special triangle. So I'll put that down here. Now in this problem, if we wanted to use sine, cosine, and tangent, then what we could do is just drop down an altitude and cut that 45-degree angle in half. That's what we did in the first problems today, but we don't want to do that if we don't have to, because then, again, we'd have to use sine, cosine, and tangent. So what we can do is drop an altitude here, and if we do that, we know that this angle is 45 degrees, obviously, and we know that this angle is 90 because, again, we dropped an altitude. And so using the triangle sum theorem, that would prove that this angle here must be 45 also. So that means that we're dealing with a 45, 45, 90 triangle. And we can use those special relations. So I'm going to pull that triangle out. It's going to look something like that. Again, it's not perfect. And we know that this angle is 45 degrees, and we drop the altitude down. And we know that this side is 9 root 2. And it's important to understand that we just need to find the height, you see. But this overall base, this base here, we already know what that is. That's just 9 root 2 because that's this side here. That's a radius. So we can just put 9 root 2. And so all we really have to do is find the height. And we don't need to know anything about these angles here because, again, we're just doing this a different way. We could just drop it down and break 45 in half, but this is going to be easier because we're going to use this special triangle. So let's start by finding the area of the sector as usual. Now you're going to have to be careful on this one because we have 9 root 2. We have to square that. So I'm going to start, there's a lot of different ways you can do this, but I'm going to start with the root. So I'm going to put 2 and then the square root button, then times 9 equals. So again, I use the square root button, but now at this point, because what I just did, I just found this inner part here, but I need to square that, you see. So then I'm going to push the square button. That's probably what's gonna look like in your calculator. So I'm going to push that button. Then you should get 162 in your calculator. So now times the pi button equals times 45 equals, then divided by 360 equals. So that's just one way to enter in the numbers to your calculator, but whatever you do, just make sure that you get 63.6172. All right, so on to part 2. We're already kind of started on part 2 because we've got that triangle. And so now we're going to pull out that triangle, and we have 45-degree angle, and we know this has to be a 45-degree angle. This side is 9 root 2, we know that. And so we're just looking for the height, and also, well, we don't really need the base because we already have it. So now let's go look at our special triangle here. We have the hypotenuse as usual, but you can see just looking at that hypotenuse, we can find W. That's the whole objective here, is to find W. Once you find W, you know what all the other sides are. So obviously W is 9, so that means that these two sides must be 9 also. So what does that tell us? It means that this side is 9 and this side is 9. Again, we don't really care about this side, we just want the height, this side. The height must be 9, and the base, we already have the base. That's 9 root 2. I'm going to put a little arrow there, maybe color coded, just so you can see where we got that base. And so the area of the triangle, now that we have the base and the height, is 1/2 times the base, which is 9 root 2, times the height. And again, you have to be careful when you enter that into your calculator. 0.5 times 9 equals, times 2, and then the root button equals, and then times 9 equals. So we get 57.2756. And on to step 3, the area of the segment is equal to the area of the sector minus the area of the triangle. Area of the sector all right, and just enter that into the calculator, and we get 6.34 square centimeters. All right, so again, the different thing about this problem is that we're not dropping an altitude and splitting that central angle in half. Instead, we're dropping an altitude like this so we can make a 45, 45, 90 triangle. Of course, we could also drop an altitude like this if you want to and make this the base. That would work also. I only did it because I want to make the bottom part the base. So we have one more problem for today, at least until you do your homework. I'm going to bring that special triangle over there so you can see what's going on. Go ahead and try number 20, and when you come back, we'll do it together. All right, we're back. So it's not as easy to see, I guess, but I'm going to make this side the base. But first, let's find the area of the sector. Notice that we have the arc measure, but that's equal to the corresponding central angle, so that would be 45 over 360 times pi r squared. which is approximately equal to, and you want to start with 2 and then push the root button, times 6 equals, and then push the square button. So I'm kind of starting from the inside and going out. That's just because that's the way the calculators work. If you do it any other way, you might have a mistake there. So times pi equals, then times 45 equals, and divided by 360 equals. So you should have gotten 28, and if you didn't, that's okay. Just go back and fix the problem. You should have gotten that answer, at least for part 1. And on to step 2. Area of the triangle is equal to 1/2 base times height. And I'm going to pull that triangle out. And we have something like this. Again, it's not perfect. And so this is 45 degrees. Again, this base here, I'm making that side. So this base is 6 root 2, because that's the radii, or the radius. And what else do we know? We can drop the altitude down, and we know that this side must also be 6 root 2. So we know that this side must be 45, and let's pull out the right triangle, the triangle on the right. And again, it's not exact, but it's these two sides are supposed to be the same length. You can see that they're not really the same length, but you know, as long as you understand what's going on here. So now I'm pulling out the the triangle on the right, and it's a 45, 45, 90. And so we're looking for the altitude, and the base we don't really need because we already have it. We have the basis here, 6 root 2. So looking at this triangle, we can see that the hypotenuse is 6 root 2, a multiple of root 2, which means that W must be 6. So that means that these sides must be 6, based on that relation there. So the height is 6, and the base is 6 root 2, because we can just see it there. I can color code that. So the area of the triangle is equal to 1/2 times the base times the height. So let's go ahead and approximate that in our calculator. So 0.5 times 6 equals, times 2, then the root button equals, then times 6 equals. So we get approximately 25.4558. All right, step number 3. As usual, the area of the segment is equal to the area of the sector minus the area of the triangle. Area of the sector is 28.2743 minus 25.4558. So the area of the segment is approximately equal to 2.82. And the units are square inches. So if you got that answer, good job. So that was the class today. So let's go ahead and get screenshots of all the work that we did today, so you can use these notes with your homework. Screenshot number 1, screenshot number 2, screenshot number 3, number 4, number 5, number 6, and number 7. But don't go before you get your homework. Let's take a look at the homework. And here's the homework. So get a screenshot there. Screenshot number 1. Screenshot number 2. And that is it. So be sure to do that homework completely and correctly and neatly and put it in order in your binder. Remember, if you don't do the homework, you're going to learn absolutely nothing in this entire course. So get that homework done, and I'll look forward to seeing you in the next class.